This standard is fermentation. Fermentation is pretty much a way that energy is made, but without the use of oxygen, or like when it happens when there is no oxygen. There's a chart that I found very helpful. It puts it in good perspective and it connects it to glycolysis and how it is connected. As we know, glycolysis, in the process of glycolysis, the end product are the 4-ATP and the 2-pyruvate. Fermentation uses the 2-pyruvate to form ethanol and lactate. And how it does this is that ATP is directly synthesized from phosphorylated intermediates of metabolized compounds without the involvement of the electron transport chain. As there is no external electron acceptor in fermentation, cells have to produce their own electron acceptor to maintain their redox balance. Instead, the NADH donates its extra electrons to the pyruvate molecules formed during glycolysis. Since NADH has lost electrons, NAD plus regenerates and is gained available for glycolysis. And like something that when I was reading, a lot of people think that fermentation has to happen in a anaerobic environment, which means that where there is no oxygen. But even in the presence of a lot of oxygen, yeast cells still prefer fermentation to oxidative for phosphorylation as long as sugars are readily available. Sugars are the most common substrate of fermentation, and typically examples of fermentation products are the ethanol and the lactic acid, and even hydrogen. Yeast carries fermentation in the production of ethanol in beers, wines, and other alcoholic drinks. So this is something that's like not just like in our body. It's something like in real life that like they use the same process to get the same end results of ethanol. And that's it.